Welcome to week 2 of IT-633 data mining, to a quick introduction to basic R. You will learn more in the lynda.com tutorial. Here we're going to look at where from to install R and RStudio. We will also review the bundled datasets that come with RStudio, and we will learn how to review the frequency distribution, the 5-number summary, and other statistics. And finally, we will learn how to build a histogram and a boxplot in RStudio. In order to follow along, please install R and RStudio. You can install R from the links shown here. For your operating system, it comes for Windows, for Macintosh, and for Linux. And RStudio is available at this link, also to install and download. In order to review the datasets that come with RStudio, all you have to do is, once you have opened RStudio, at the command line type data, open paren, and close paren. This is what this looks like. Data, open paren, close paren, will show you all the datasets that come with the datasets package in RStudio. In this demonstration, we will be working with the loblolly dataset, which shows us the growth of the loblolly pine trees. In order to review the dataset that you have chosen, just type the name of the dataset into your command prompt. As you can see, I am now seeing my dataset along with the height, age, and the seed. These are obviously the 3 attributes in my dataset. And I can already look at, when I look at my dataset, I can already see that there is something interesting going on with seed here that's different from height and from age. To produce the 5-number summary, we are going to type the word summary with the name of the dataset in parentheses at the command prompt, as shown on this slide. Here we are seeing for each attribute, height, age, and seed, the 5-number summary, the minimum, the maximum, the first quartile, the third quartile, the median, and the average. We're seeing this for height, for age, and for seed, and we're already seeing that the seed attribute is apparently different. How different it is, we will find out in a little bit. In order to look at the structure of a dataset, including the data type of the attributes, we are going to type str and then in parens the name of the dataset. This will show you the number of attributes, the names of the attributes, the number of the observations for each attribute, and the variable type. Let's take a look at this in real time. So I'm going to adjust the width of this window a little bit. Here we go. So what I'm seeing here is I have 84 observations. I have 3 variables. My variables are height, age, and seed. I'm seeing that my height attribute is num, that is numeric. I'm seeing that my age attribute is num, also numeric. And I'm seeing that my seed attribute, which we've already seen is obviously different, is an ordinal factor with 14 levels. It goes from 329 to 327 to 329, 325, etc. So, having said that, this is going to inform what kind of mathematics I can do. For example, if I decide that I want to summarize the values of my columns, that is, of my attributes, then we will see that summarizing, which we do with the operator sum, and then in parens the name of the data set, and then a $sign and the name of the attribute, that will work only with numeric attributes. So I can type sum loblolly $height, and I get the sum of all the heights of my trees. Whether that makes sense or not for my analysis, that's a different story. I can do the sum of my age, and here we go. But if I do the sum of my seed, I will get an error because this is an ordinal attribute. I cannot summarize an ordinal attribute, the values of an ordinal attribute. Now, the standard deviation I can calculate. I can calculate the standard deviation with the SD operator. Again, I use in parentheses the name of the data set with a $sign and then the name of the attribute. So if I want to, for example, calculate the standard deviation of my height attribute, this is what I can do here. Same thing with my age attribute. And I can actually calculate the standard deviation for the seed attribute, but does it make sense? Not really. Because again, it's an ordinal attribute. Finally, let me introduce you to the real power of RStudio, which is in the graphics. I can build a histogram and I can build a box plot. Here's how this works. To build a histogram, I type hist, in parens the name of the data set, a $sign, and the name of the attribute of which I want to build a histogram. Hist loblolly, and let's say I want to look at the height attribute. As I type enter, RStudio will display a histogram in the lower right hand corner right here of my attribute. I can do the same thing for my age attribute. Here we go. And let's see what it looks like for my seed attribute. Oh, and again, I'm getting an error because my seed attribute is ordinal and not numeric. So, however, I'm able to build box plots for all three attributes. In order to build box plots for all three attributes, all I have to do is type boxplot and then the name of my dataset in parentheses. As I hit enter, I see in the lower right hand corner all three of my attributes and their box plots. I have the option as well of focusing my box plot on just one attribute. Let's pick the height attribute. So I specify $height as the attribute which I want to show. And here is just my height attribute. Good, so what have we discussed? We have discussed where to install R and RStudio from. We have looked at the bundled data sets. We have learned how to view the frequency distribution. And we have walked through the commands to produce the 5-number summary and other important metrics. Finally, we have learned how to build a histogram and a box plot in R. This requires that we install R and RStudio. If you would like to get fancy and add color, there's a really awesome blog entry by the R bloggers, and that will walk you through a tutorial of how to make fancy box plots. Thank you so much and have a great week.